It's very nice to be here again. Thank you for having me again on DevOpsDays. And as Rafał mentioned, my name is Kamil, and I'm currently working in Container Labs as a DevOps architect and a consultant. I mostly focus on DCOS, Kubernetes, and Mesos. I also work with Terraform, SaltStack, and Ansible. And because I'm very, very, very lazy, I'm a kind of automation freak. I try to automate everything I can. And you probably saw these slides today, most of you, so I'll just go over very quickly. In Container Labs, we do a lot of public cloud and private cloud. We work with a lot of cloud-native technologies. I won't mention them right now because you already saw that. And we also work with several big companies around the world. So we also provide a lot of trainings from these technologies that you saw on the slides. So enough of marketing talks. Let's go over to the infrastructure as code. So let's go back to the year 2000. Probably most of you remember these times. There were bare metal everywhere. You just go over to the data center, put bare metal into rack, cable it, power it, configure. Everything is very, very cool that you configure everything manually, and you write zillion of pages of documentation. You have your own IT department that's camping in their caves in some basement, and everyone is happy, right? Everything was cool. And it was very, being happy doesn't mean that everything works around. You can be happy when there's a fire around. So, what really happened in 2000? There were several issues. Most of you probably know these scenarios. Like, let's hotfix this on production really quick. We don't have time. Everything is burning right now. Clients are calling us. So let's make a hotfix. We'll document that later. No worries. There were also several like bare metal servers or instances that were completely mysterious, deployed by Wizard, that doesn't work in this company anymore. So no one really knew how this was configured or deployed or what's inside. Is there an Nginx or Apache or whatever? So there was no knowledge about the infrastructure at all. And as I previously mentioned, there was a lot of missing documentation, missing knowledge transfer between employees in the company. And another important issue is that developers and operators really hated each other. When developer came to the operator and asked for a server, there was, of course, there was no problem, as you just have to wait several weeks. When I order a new bare metal server, put it in the rack, cable it, power it, configure it, and it's done, right? You'll have your new server in 2 weeks. So these were the obvious issues, and let's travel in time again. Now we are in 2009, and this is most likely the rise of the virtualization. Everyone was saying that virtualization is a cure for every problem in the world, even cancer. So who was the savior of the world? Of course, VMware, as the major player in the virtualization world. As you can see on Google Trends, there was a lot of peak around 2009. A lot of people were getting interested in virtualization. And having VMs around started to force people to automate things, since they already saw that automating things around can solve their day-to-day operation issues. So a lot of new software was developed, like Puppet was gaining popularity. First version of Chef was released, so there was new tools that helped people to start automating things. And there was, of course, there are some issues that were addressed compared to the 9 years before. Like deployment of the VMs was much faster than deploying a bare metal server, as you don't have to cable, power, and configure. There were a lot of manual, were less manual changes than before as people started to get interested in configuration management tools. Slightly less documentation as the automation goes on. And of course, better infrastructure visibility due to having single pane of glass on the infrastructure compared to the large amount of racks in the data center. But the new issues have arrived, like mysterious servers or mysterious bare metal servers were replaced by mysterious VMs that no one ever saw again. And strangely, when they log in into vCenter and see instance 1, and they are thinking, what's that? How did this get deployed again? So the bare metals got replaced by VMs, zillion of pages of documentation again, but slightly less than before. Still, people were doing hotfixes in production because clients asked them to. No documented live modifications. Of course, let's do some testing on our production systems. Everyone does that. And never documented, never applied anywhere. No one knows about that. No BKMs, etc. Of course, deploying VMs was faster than deploying bare metal servers, but it was still slow enough for developers to catch up. And of course, visibility into infrastructure was was much better due to single pane of glass on the whole infrastructure compared to the bare metal. And let's go to the 2017, as we probably heard a lot. You can guess who's the savior of the world now? Which software is the savior of the world now? No, Kubernetes. Yes, everyone is very hyped about Kubernetes. As you can see, he's the new savior of the world as compared to the VMware. And as you can see on Google Trends, it has spiked like madman recently. And infrastructure as code has gained a lot of popularity. A lot of people got interested in this methodology, how to do that, how it can solve their problem they are having on a day-to operations. A lot of new cultures have emerged, like no-ops, DevOps, serverless stuff, etc. So a lot of new terms, a lot of new methodologies, a lot of new tools got released. A lot of people are getting interested in automation. And everyone is talking about microservices, nanoservices. So these are the new cool kids on the block. Everyone does that. Everyone wants to do that. And everyone tries to get into that trend that's very popular right now. But there are also still some issues and some new issues, like lack of proper CI/CD pipeline. A lot of talks today got mentioned that the culture is very important. And of course, this is a huge issue right now while trying to switch to the new methodology. And it's mandatory to shift the culture in the organization to succeed. Automation requires a lot of resource investment since people have to learn new tools, new techniques, reinvent the whole infrastructure. And there are a lot of tools to choose from. So people just see like 15, for example, if you go to the shop and you see like 10 waters and you really don't know which to choose, right? You just grab the first one or the one you like. So the amount of tools available right now just mess people up, and they are not able to choose the proper one based on their requirements. They just go with the hype. So I was like going back into times, and I didn't really explain what is infrastructure as code. So basically, this is a methodology that allows you to describe, test, and deploy your infrastructure as you would with your product. So with the software that you're writing, with the code base that you're developing. It is reliable and consistent as you have everything written down in one place, everything is visible, everything is completely clear and transparent to the other people that you're working with. Do you know what dry means? Hands up. All right, so it allows you to, dry is abbreviation for don't repeat yourself. So it allows you to write less code and do less repeatable tasks than you would before. So you just write the one thing and reuse that in other components. So infrastructure as code allows you to do that with your infrastructure. And one important thing, which is also worth to mention, is that promotion across environments. So probably you would, in ideal case, you would like to have a development environment, staging environment, and production, and all of them look the same, right? So you just can promote your change from development environment to the staging to the production, etc. Because they all look the same, and it's not a very difficult thing to promote the same change that's not very influencing the environment itself. So what problems does infrastructure as code solve? So it increases the visibility into infrastructure, as you have everything written down in as code. If you even understand a piece of it, you have a complete vision how components are connected with each other. Version control doesn't matter if it's Git, Mercurial, whatever, which one you prefer, SVN. Allows you to help tracking and doing rollbacks of the changes in the infrastructure. So you always know who did the change, what was changed, when it was changed, when it was applied to the infrastructure. So you have a complete history of changes into your infrastructure. So no Ninja patches again on the production. Having a CI/CD pipeline greatly accelerates your deployment process, as you treat your infrastructure as you would treat your software. So again, you just build your infrastructure, test it, and deploy. So these are the three main steps that you would do with your software, and you can do that with your infrastructure. And having CI/CD accelerates that by completely automating the whole process of product delivery and infrastructure delivery. It's much easier to maintain an exact replica of the production environment, so you can just clone the production to the, for example, test environment that you would like to test new feature on, as you have complete description of the production environment as code. And there is much lower risk of errors due to automated tests of the infrastructure, as you test your infrastructure as you would test your software. So, what can possibly go wrong in this? It's very cool, ideal, there are no problems. And there are a few cases in which things go bad. And as I mentioned, and a lot of talks today also mentioned that culture is very important. So without shifting the culture in our organization, this methodology won't work at all. It is important to build a trust and empathy between developers and operators. So the bonding between them has to be strong in order to cooperate with each other. Also, it is important to eliminate blaming and pointing fingers at people, so people don't feel offended or feel guilty about something if they happen to screw up. Nothing happened. Let's learn from that and go on. Embracing smart failure means you have to build the systems that are failure resilient, and even if it happens, you have to be prepared to roll back. So if you have the complete history of changes, it's much easier to know what happened and which components could be influenced with this change than guessing what was changed in Nginx configuration. When I was working at Intel, some very wise man said to me that it is important to fail fast. So in order to do the R&D properly, you just do a quick POC of new solution, and then if it fails, it fails. But you wasted like 3-4 days, 1 week. But you know that you could look at another solutions that are much better or a better fit to your requirements than spending 2 months working on a perfect solution that could work, but you have no guarantee on that. Eliminating unplanned work. So doing things that are completely unplanned. Of course, there are some failures or scenarios which you cannot expect, but trying to plan work that's ahead of you with the infrastructure is very important. And also with that goes on being continuous. So if you do infrastructure as code, just go over and do that as code. Never go doing manual changes as you screw up and just go over to the old methodology. It's very hard to come back from that, as you have some kind of several manual changes, several codes, infrastructure as code written, and it's very difficult to combine that together again. And also one more important thing is to be transparent and share the knowledge with your colleagues. Of course, there are some people that think that having a complete wisdom about some components is very crucial, as you want to get fired because they cannot fire you. But sharing your point of view with your teammates might result in a complete solution that you never thought of, and this could lead to some great things that you could develop later on. And another issue that might occur is that automating everything is very difficult, especially if you have infrastructure already running. It requires an effort from an engineering team to learn new tooling, new methodologies, how to describe the infrastructure in new way, and it is also difficult to describe the already existing infrastructure, as you have some connections that you're not aware of. You don't have the full visibility into infrastructure, so it's very difficult to guess how all things are connected together, and it's of course very time-consuming. Another issue that might occur is a wrong choice of tools. So using tools that have a different purpose. How many of you uses Terraform? Okay, and how many of you heard about Terraform? Okay, more hands. So, for example, using Terraform Remote Exec Provisioner, that's some kind of like connecting with SSH to the remote machine and executing some script and going back to do advanced configuration management. So you write a very long script that configures your instance, put it in Terraform, and voila, everything works, right? Terraform was not designed to do that. It's supposed to build infrastructure, not configure infrastructure. So you have configuration management tools. You can choose off from variety of tools and stick with configuration management tools and use Terraform to actually build the infrastructure, not configure it. Another example of choosing wrong tools is that you use some tools that have the same capabilities. So for example, you mix SaltStack, Chef, Ansible, because Ansible has some feature you like, and Chef has some feature you like. So you use both, right? Instead of, you should just stick with one, don't mix that ever again. And the worst thing that you can do is choose the tool based on its popularity instead of evaluating your own requirements. So Kubernetes is a great example of that. I see a lot of people that are going, oh, Kubernetes is very cool right now, let's go Kubernetes, right? and they only need to deploy 2 containers. Why Kubernetes? You don't need Kubernetes for that. So always choose the tools based on your requirements, what you really need. Don't overkill the infrastructure with whole stack of tools that you won't use ever again just to deploy 2 containers. And for example, some tools that can help you with orchestrating your infrastructure. Most of you already know Kubernetes, DCOS, Docker Swarm, but also Google Kubernetes Engine and ECS from Amazon. As for the tools that can help you with configuration management, most of you probably know SaltStack, Java, Ansible, Puppet, etc. There are more of that. As for infrastructure as code, Terraform, CloudFormation are great choices. There are a lot of other tools that can help you with that, but just the one I know and I like really. So as for CI/CD, Jenkins, Bamboo. Everyone hates Bamboo, right? So who hates Bamboo? Hands up. Who hates Atlassian? Hands up. Okay, cool. Not many of you. I'm surprised. And also, of course, Travis as for GitHub. Another issue that's very frequently occurred in my experience is that some tools miss some fundamental things that you would expect this tool to have. For example, with the configuration management, infrastructure management tool, you would expect to have conditionals, right? Simple if. Terraform doesn't have that right now. Of course, you can do that with some hacky ways with count, but it's not a real conditional, right? That's a basic functional thing that you can do that conditional in your infrastructure, but it doesn't have it. There are a lot of other like loops over modules, dependencies between modules, looping over attributes. These are the fundamental things that you would expect the tool to have, but it doesn't actually have that. But they are highly working on that, and probably it will be released soon. Let's hope so. For example, DCOS from orchestration platform, you would expect an auto-scaling solution. No way. Secrets management, role-based access control, maintenance mode. These are core functionalities that you would expect to have. None of them are available in DCOS open source. Not talking about enterprise version. And as for SaltStack as configuration management tool, very poor quality of documentation. Anyone uses SaltStack here? Whoa. Not many of you. I'm not surprised. The documentation is crappy. Never, ever again. And no support for grains and pillars. These are like variables in SaltStack Reactor. It's very hard to customize that without these functionalities. What can go wrong with building CI/CD? So you can always use it as a build, test, and deploy. And of course, you have a version control under it. You should always use like pull requests to build your infrastructure. So having several reviewers of the infrastructure code would greatly benefit in this scenario, as it allows you to have another pair of eyes on what you have written, and having a review would greatly improve what could happen next. Automatically promoting successful builds across environments. Some of people agree with that, some of them not, as it poses some risk. It highly depends on the next point, which is test coverage. But as long as you promote the builds between dev and staging, it's okay, as you have a high test ratio, and nothing could possibly go wrong. Even if it does, it doesn't really matter, as it is not production. But it's cool to have a one-click button, like you have all of the test suite around that allow you to see the visibility of all of the infrastructure code. Everything is green. Click, deploy on production, works. So as an example, how this pipeline with Terraform could look like is that you have a pull request, then you run the Terraform plan, and it's executes plan against the infrastructure that you already have, and compare the changes that could be applied. If the plan was successful, then you apply the changes in a dev environment, and if the apply was successful, you just run the infrastructure tests. So you test the connections, test the components, load balancers, etc., etc. If everything goes okay, you try to run application tests. So if the infrastructure is okay, let's see if application is still healthy with these changes that we applied. If these tests were successful, we promote this pull request to the next environment, like staging, and do the same circle again. If not, we just roll back and see and notify the operator that something was wrong. As for the maintenance, there are three key things like mutable or immutable infrastructure. My colleague previously mentioned that very briefly. I will go over in slightly more details. Cloud-init versus configuration management. For those of you who uses AWS, Cloud-init is very familiar. For people that use OpenStack also. For those who don't know what Cloud-init is, I'll go over in a second. And maintaining multiple and identical environments like dev, staging, and production. So who remembers that? Hands up. Tamagotchi. Yeah, cool. So what is mutable infrastructure? These are mostly pets. So these are instances, servers, etc., that you take care of, feed them, log them out, etc. Apply updates, tweaked, tune. Everything happens in place. And they're only replaced if the failure occurs. So as long as everything is fine, they live and they are very happy. Compared to immutable, these are components that are designed to be an exact set of specifications. So you create a specification of a component, or for example, of an instance, and you build that component based on this specification. So no changes, no tweaking, no updates, etc. If you have to apply some updates or some changes into operating system, you just destroy the old one and create a new one, like a paper cup. So you just use it once, throw it away, and you grab a new one. And because of that, the components are very frequently replaced, and they are completely reproducible. So you always knew what the set of specification is, and you're always able to reproduce that component from scratch. And what are the pros and cons? So immutable infrastructure fits perfectly into infrastructure as code pattern, as you already have the infrastructure description, so you are able to create an infrastructure very easily. But it's not always possible to go completely immutable. Sometimes you have components that cannot be destroyed so easily, like databases. Mutable infrastructure allows for a lot of exploitation. So you have people that are not very happy of the methodology that you're using, so no changes on production. And they still go over to the production servers and change some configuration, and they're very happy because client asked them to. There was fire and you had to change that. And because of that, in immutable infrastructure, that won't happen, as you just replace the component and the manual changes are gone. One thing that's very frequent in mutable infrastructure is that you fix something and it's broken again, and then you fix it again, and you fix it again, and again, and again, and again. And it happens to pile up, and then everything dies. In Mutable, it won't happen ever. And it's also difficult to keep up with multiple identical environments while you have mutable infrastructure, as you perform some changes inside of the operating system, and it's very difficult to track them down. Compared to cloud-init, cloud-init is like one-shot unit inside of the operating system. So you provide a set of commands that are executed at the first run of the instance, and they are not executed ever again. And it highly depends on a mutable versus immutable infrastructure. Cloud-init is a perfect fit for immutable, but it won't work in mutable infrastructure, as you have to destroy the instance or force cloud-init again to perform these changes. And configuration management like SaltStack, Reactor, can be a good replacement for an immutable infrastructure, as it allows you to do the same thing as cloud-init, but in a much easier way. So let's go over to maintaining multiple identical environments. And in this scenario, choice of the approach is the right approach is the key. You have to keep your code dry and use the tools that might help you with that. For example, if you use Terraform, it is good to get familiar with TerraGrunt. It's a wrapper around Terraform that allows you to do some magical stuff that Terraform normally won't let you do that. And of course, try to keep a separate version control branch for each environment, so you have a complete track of changes between environments. And how repository of Terraform could look like in this scenario. For example, you have two repositories. One is infrastructure that contains a skeleton of the infrastructure layout, so no variables, environment variables that are specific for each of the environments, except for defaults that you have. And Terraform Live, which contains the actual live environments, like you split it up by regions, by environments. You have the values for each environment, like passwords for databases, etc. And you just include the subdirectories from the Terraform infrastructure repository into live repository. So as an example, this is how infrastructure repository looks like. So we have three directories, VPC, DB1, DB2, and the Terraform configuration inside. And in live, we have two environments, environment 1 and environment 2. In environment 1, we have VPC created and DB1, but we don't want database in our second environment, so we only include VPC. And because of that, we have a complete skeleton of the infrastructure, but we don't have to use every block in that skeleton. We just select the blocks that we want to use in each of the environments. To conclude, infrastructure as code greatly improves visibility of your infrastructure, as you have complete description of each of the components, how it's configured. Dependencies between components are also very visible in this approach. So it's much better to understand for at least new people that come to the organization how this works, or components that are how components are talking with each other. Treat your infrastructure as you would treat your software. So build, test, and deploy as normal software deployment pipeline. As mentioned, shift in the culture is most crucial requirement to succeed. Without that, you won't be able to adapt any of those things, as you will always have people that drag you down. And it's much better to cooperate between people than blaming and pointing fingers that you screw up, just go fix that. very important thing that I already mentioned, always choose tools that are based on your requirements, not on their popularity. So never choose Kubernetes if you have to deploy 2 containers. Building a proper CI/CD pipeline would greatly accelerate your infrastructure deployment and overall maintenance of the infrastructure. And one thing to always remember, that no tool or methodology is perfect. So try to adapt it to your requirements. For example, you could work with Scrum, but there are some pieces of Scrum that don't fit in your requirements. So you just adapt the methodology to your actual needs. This is true also for tools, for methodologies. So if something is not very, you're not very happy with infrastructure as code of some component, try to adapt it on your way. So this is there is no perfect match or no perfect solution that could solve all of the world's problems. Thank you.
Thank you so much. Okay, we are ahead of time, so we have time for questions. That was the first question here.
Hello. Do you have any bad experience with using Terraform on production?
Yes, as you would expect. First bad thing is when you describe your infrastructure as a big piece of Terraform files. For example, I mostly use AWS, so when I apply these changes, I just get rate limited by AWS API, and Terraform goes nuts. So try to split the configuration into smaller pieces like modules, and apply them in smaller blocks. So you won't hit the API rate limit.
Am I correct? Do you suggest to use a separate TF state file for every environment?
Even smaller blocks, like each of the components, like you saw on, for example, here, VPC and DB1 would have a separate TF state file for each of the, so you just go over to the directory and apply the only one piece, like VPC only. And if you check out, I'm not sure if you're familiar with Terragrant, it allows you to you just would go into env1 folder and do apply all. So you don't have to go into each folder and apply all of them. Terragrant keeps the dependencies, so it would go into each folder and execute them in order you would have. So it greatly accelerates the deployment process.
Hey, I'm wondering what's your opinion about mixed solutions. For example, if I have partially mutable, partially immutable infrastructure, what I mean here is that, for example, I have instances that live no longer than 5 hours, but they are configured partially by cloud-init, partially by configuration management systems, and any update is it's not rollovering the whole infrastructure, but it updates the particular instance. So I'm wondering if this is a good approach for our infrastructure as code.
Yes and no. It highly depends on the use case you have.
CI environment.
Okay, so if I understand that correctly. You have you spin up the environment for some CI tests, right? And then you just throw it away, right?
But not exactly. Well, but mostly build slaves. Okay, so I have a dynamic auto-scaling group, which is scaling based on the queue on, for example, Jenkins.
Okay.
And I configured the instances by, for example, I don't know, SaltStack, Ansible, or whatever. And if I apply a change to my configuration management repository, it's updating on the particular instance. But the initiation is from a cloud-init.
Okay, that's a fair enough approach. Not what I would do personally. I would just stick with either configuring everything as immutable, so you just every change destroys the old ones and creates a new ones. As long as you don't have persistent data inside, it's okay. I don't see any point of keeping those instances around. But it highly depends on your use case and requirements.
Okay, I have a question. So what should I use if I have 2 containers?
Sorry?
What should I use if I have only 2 containers?
I won't say Docker, but Docker.
Docker.
Let's go Docker, Docker Compose or whatever, Rocket.
Okay. Any questions? Any more questions? Nope. All right. So I think that we have right now a coffee break scheduled. So please, thank you, our
Thanks.
speaker.